welcome back to your next video tutorial, Math Experts. Yeah. So now we are going to see how to take. We are now taking the derivative of natural logarithm. We are going to see how we can take the differential of what? Exponential functions too. Okay? Alright, and you will have it. Now, from your algebra, you know that A is the same as e raised to the power ln A, right? Because this will cancel this, so it's the same thing. Alright. Then let's multiply both sides by x and see what we are going to get. So multiply this by x, multiply the whole of this by x. And we are going to get something like a raised to the power x is equal to e raised to the power x ln A. Sorry. Okay, ln A. So what we are having in the left hand side is the same as what we are having in the what? In the right hand side. Alright. And now we are saying that we want to take the derivative of exponential function. And we can see that this is something like an exponential function. Okay? Now the exponential function, it can be a function over another function or a constant over another function. Okay? Alright. So now we are going to let's assume f of x is equal to a raised to the power s is equal to e raised to the power s ln A. So, to take the derivative of this is the same as we taking the derivative of this. If yes, then f prime of s is the same as e raised to the power s ln A. Alright, so having this, we want to derive something. So now, having this, having e raised to the power s ln A is going to be equal to, now watch what? I'll tell you the reason why later. We are going to leave anytime that, anytime that you are taking a derivative of an exponential function, let's say e, raised to a certain power of a function, you will repeat everything here. Okay? You are going to repeat everything here, which is this. Then you multiply by the derivative of the power or the exponent, which is x ln A. Now, let's continue. So this is the same as e to the power s ln A times. Now, to take the derivative of this, be careful, it's not a product rule, because we have already defined that the A there is a constant. Like 2, 3, 4, 5, anything. It's a constant, right? So if the A is a constant, then ln A will be a constant. So to take the derivative of this is the same as you taking the derivative of 2x. That you will say 2. Alright. So to take the derivative of this is going to be, or to take the derivative of, let's say, 2x. You can bring these 2 out and take the derivative of the what? Of the only x. So, we can write these 2 as bringing the constant out, then taking the derivative of the function, which is what? X. How we are getting it? Alright. So now, this is going to be, so dy ds is now going to be equal to ln A, knowing that this will be what? times e to the power s ln a. I hope you can see that. Alright. Now therefore, in general, if the derivative of this is the same as this, and we are getting this, then in general, it's not always that the a will be raised to the power x. The x there is like a function. The function can be in terms of anything. So in general, let's say we are going to let u, or let's use f of s. So the derivative of a raised to the power g of s, since I have already used f of s, g of s is going to be equal to ln a. Then you take ln a, then you repeat everything that you see here, because if the derivative of e raised to the power x ln a is this, then it's the same as you taking ln a, then repeating everything here, which is a g of x. Then the derivative of the function, and that function is g of what? X. It's just simple. When you are using it to solve question, you get it well. It's just simple. Anytime you have a function, let's say a constant to the power of a function, you just take ln a of the constant, repeat everything there, and take the derivative of the what? Of the function. That's how it is. So now, I'll be back so that we see how we can use this idea to derive a lot of what? Questions. But before that, looking at what we have established here, you can see that if y is equal to e to the power x, or u, this is a constant, right? So the derivative of e to the power u will be equal to ln e, because that's a constant. Because e is 2.7 something. Then you repeat the whole thing. Then you take the derivative of the what? Of the inside. Or of the exponent, which is what? U. So this is going to give you, this is 1. This one, it will cancel to go. So e raised to the power u. Then the derivative of what? Of this dx. So that is how we take a derivative of any e raised to the power of any function. So don't forget it. Anytime you have such function, know how to go about it. So using this idea, yeah, you can say that the derivative of, I want to establish something before we get to solving the questions. The derivative of e raised to the power x is going to be e raised to the power x. How you can see that? Straight away, or you can see it. Alright. So now let's see. Ln of e, that we know, me and you, we know is 1. Alright. Then repeat everything. Then the derivative of the exponent, which is x. So this gives 1, e raised to the power s. These two will give 1. So you see the result is e raised to the power s. So we are getting to solving more questions, but be okay with it that anytime you are differentiating e raised to the power s, your result is the same as e raised to the power s. This is when normally people say that if you are going to marry a woman and the woman is e raised to the power s, if the lady is having a bad behavior, don't be thinking that you can change it because of the e raised to the power of s. No matter what you do, the lady will still be the same thing. Is that true? It's up to you. Alright, so that is how we do it. Don't forget it. We'll be back to solve a lot of questions under this. Okay, until we meet again. Bye bye.